Okay, let's talk about electric motors. Most of the appliances in your kitchen have some sort of an electric motor. And these motors are very, very simple. All you have is a current carrying coil that's free to rotate. Okay? Now, if the current in that coil is coming towards you at the top and away from you at the bottom, that's going to give you a dipole that is pointing like that red arrow. Now, think of this coil as a bar magnet that's free to rotate. Well, a bar magnet that's free to rotate is just a compass needle. And it's going to line up with this external magnetic field that is somehow created pointing towards the open door. Now, that coil is going to line up and stop. And that's not a very effective motor. You know, if it just turned a little bit and stopped, you'd call that broken. What happens in a motor is when it gets lined up, we magically switch the direction of the current. Okay? Watch what happens to this current right here. It's going away from you. As soon as it lines up, we magically switch the direction of the current. That switches the direction of the dipole, and now that little compass needle's not lined up anymore. And so it keeps rotating to line that up. As soon as it gets lined up, we again magically switch the direction of that current so that it keeps on going. Now, the only complicated part of a motor, electric motor, is how to magically switch that current direction. And we do that with commutators. Lousy commutator. Okay. That's what we have in the Cold War, commutator. Okay. This is the commutator here. They're sometimes called bushings, brushes, different names for them, but essentially it's just a lead that's connected to the positive terminal of the battery. And when this coil rotates around, this side of the coil is touching the lead for half a turn. And then when it turns half a turn, this side of the coil will be touching the lead that goes to the positive. And so every half turn, I'm going to reverse the current through the loop. And we set it up so that that's just at the right time to keep my dipole, my little compass needle, always needing to line up. Now I have here an electric motor, a very simple one. You're going to make an electric motor, not this week, but next week in tutorial. Even simpler than this. Now that last tutorial next week has no homework. Yeah, I'm sorry. That means that it's all attendance. 15 points for showing up, 0 if you don't. So don't miss that next tutorial. Now you'll notice in this simple motor that there are two coils. There's one coil that's fixed that can't turn, and another coil that's free to rotate. Now we use this coil down here to generate a magnetic field that's constant, that's always pointing towards you. I turn on this battery, and essentially this field is magnetizing these two arms, so that this north pole and this south pole have a field pointing towards you. Now this second coil can turn in that field. And when I turn on this battery, I will get a current and that causes it to be pushed, always lining up with this field here. Now, how do I switch the current back and forth? Well, those of you in the back are going to have a hard time seeing this, but I've got these little metal bars here. And the leads to my coil are brought into this collar. But the collar is not all the way around the axle. It's two collars, two half collars that are separated. You see that line of black there and that line of black there? I've got two half collars like this. And as it turns around, each half turn, I have a different half collar touching this lead here that goes to the positive lead of the battery. Now, what would happen if I switch the leads? With the leads like this, it goes around that way. The more current, the faster it goes. Let's switch those leads. Now it goes the other way, and the more current, the faster it goes. Okay. See if your neighbor understands motors.